Welcome to my work solutions for the AQA Foundation paper from the June 2024 series. It's paper 2, so calcs aloud, and hopefully you'll think that this is the non-waffly version, unlike the others that are out there. So to convert a decimal to a fraction, think about place value. The smallest digit, the 7, is hundredths, and that's all you need to know. It's 27 hundredths. I know you can sneak in your SD button on your calculator, but best off knowing. Here, you can again sneak in your SD button, but really don't forget it's 2 divided by 5. How many 5s go into 2? Good revision to bus stop it just in case you don't, if it's a harder fraction, if it comes up on a non-calc paper, that's how you go about it. But it's 0.4 for the mark. To convert a decimal to a percentage, that's a multiply by 100, shift decimal points, however you think about it, as long as you end up with 35. Some algebra, simplifying if there isn't a number, there's a 1, you've got 1 and 4 of the same thing, you've really got 5 of that thing. When you are multiplying, you multiply common numbers, letters, and so 5 times 2 is 10, and there's nothing to do with the W. Here, similar approach, 2 divided by, well, there's no number there, so it's a 1. 2 divided by 2, and m divided by m, they cancel out. Don't bother putting m to the 0, although technically it's true. Y times y times y, don't forget that's y cubed, not 3y. On we go. We have a quadrilateral. Obtuse is any angle greater than 90, lower, smaller than 180. The only option there is option C. When it comes to the acute angle, there are 2 options because there are 2 angles smaller than 90, but you only need one of them. Lines of symmetry, nope, there are none. Number 4A. To find the cost of 7 things, yep, it's a multiply. It's calc paper. You don't need all this working out. You don't need all that room. Type in times 7 on your calc. That's why it's only a mark. 5 cucumbers, there's your total. Again, no need to use all that space. Don't know why they're bothering. Finding divide by 5 will find you the cost of 1. And the only bit you need to write down, well, you don't even need to write it down, because as long as you get £2.56, you'll get the marks and you can move on. We have a pictogram. They're getting a bit more adventurous with pictograms. They're doing bigger values on the keys. Before I delve into any of the waffle, it's all about this. I like to write down at the end, there's 5 of those symbols. There's 2 of those symbols. 6 of those symbols will be 120. A quarter will be a quarter of 20. So there's your 125. Most of that information will be required for a question. You can guarantee it. Maybe not all, but so what? The company sold more plastic than glass. There we go. It's a takeaway, or you could have realised there's 3 extra symbols. It's 60 either way. The company sells each steel bottle for £17.50. You'll be reaching for your calculator, typing in 125 multiplied by 17.5 to get £2,187.50. Again, much more working out room than you actually need to use. Number 6, complete this statement. A to B is ignore the diagonals. That's not 1, that's 1.4-ish. Diagonal is longer than the horizontal or vertical. And same here. It's all about either E to A or D to C. So A to B is 5. A to B is 5 times bigger than D to C or C to D. 6B, draw a rectangle with the same area Well, count them up. Whoops, 3, 4, 5, 6, 7, 8 full ones, 2 halves to make 9, 2 halves to make 10. So when you're drawing a rectangle, I would recommend either a 10 by 1, it does fit, or what we got there's 5. Me and technology, never great. Told you, because of course I meant that to be 4. Have I saved it? I don't think anyone noticed. No one noticed, but 5 by 2 or 10 by 1. Number 7's a strange one. I'll tell you what the mark scheme says. So obviously on the original printouts, when you measure them, if you've done this on official paper, it's equilateral. So each of them should be 7.4. So you treble it and you get 22.2. The mark scheme allows 0.6 either way, 21.6 to 22.8. But in your school, there'll be different printers, different photocopiers, etc., etc. So it might be a smaller size. Your teacher might even have reduced it down to those booklet sizes, in which case it's a heck of a lot smaller. On my printout, I get 6.8. So when I treble that, I get 20.4. So again, as long as you give yourself a fair amount of leeway, you're fine. Number 8, wordy, waffly, kind of probability-ish, but not quite. How many red cubes are in the box? So, green, red, blue, white. Green, red, blue, white. 17 are green. The rest are equal. You could call them X's. That is the way I've done it on my original. But you could just do 56, take away the 17, you're left with 39, and the 39 must equally fit into each of those, so divide it by 3. For this one, 24 more are added to the box, so our new total is 80. The probability of a green is 0.4. If you get them multiplied, that will tell you there are now 32 greens in the box. How many of the 24 added were green? There are now 32. There were 17. That's a difference of 15. Number 9. Again, they've given you more than enough space. It's all about the cost of electricity to travel 270 miles. Miles to units goes from 3 down to 1. We need to divide by 3. That'll give us 90, but there's no need to write that down. We can just straight away times it by the cost of 50 pence. Or if you want to get your answer straight into pounds, times it by 0.5. If you did it in pence and got the answer 4,500, that's fine. But obviously you'll need to realise that's in pence, divided by 100, because it's got the pound sign in the answer. For number 10, we've got 2 metres of linen, £8.50 per metre. Stop. Don't read on. Get them multiplied so you know it's costing £17 for the 2 metres of linen. The total cost is 38. If you subtract them, the difference is 21. And it's for that £21 that she bought 5 metres of cotton. So we need to divide it by 5. You get 4.2. In other words, £4.20. So much waffle for this one. Feel free to have a read of it. I'm not going to double read it for you. The fact is, we're saying that for £10, how many can we buy? Let's take the £10, divide it by, turn the pence into pounds, we get 15.3, etc. In other words, for £10, 15 buttons can be bought. She says the greatest number is 14. Is she correct? Nope. Show working. I have done. On we go. Number 11, as I've already messed up the rectangles question, as you can see, didn't fancy my chances on this one. You can plot as many of those as you want. I just plotted 2. I plotted the ones which were whole numbers. It was that one and that one, because the others are halves and can be tricky to guess. But either way, join them up with a ruler for your 2 marks. For part B, couple of ways of doing this. One way is use your graph. Get a ruler, go up to your graph, go along, and hopefully you get 8.5. If you've done it that way, do use a ruler, because then the mark scheme allows plus or minus half a square. You might not have done that. You might have gone for the algebra way. In which case, when x is 2.5, if you substitute it in, y will equal 3 lots of 2.5. Add 1, and you get 8.5 on your calc or with BidMass. Wordy waffly for number 12. Let's take it ourselves through the logic. These numbers must be in order, starting with the smallest. The last digit is the only square number. Well, single digits can only be 1, 4 and 9. Well, if the last digit is the only square number, there's no way that 1 can be up here. Also, the middle digit is the only even number. So the final digit just has to be 9, odd and square. These others must all be odd, and they can only be in order, and this cannot be 4. So it could be a 2, but no, it can't, because there's no way that can be in there. What are the other options? Well, it can't be 2, it can't be 4. Can it be 6 or can it be 8? Well, it just can't be 8, because if it was 8, what on earth goes in here? It has to be 6. Other options now, we can't use 1, so we're only odd numbers. We can use a 3, we can use a 5, and we can use a 7. Well, actually, they fit in nicely. Come on, Al. Not having a good day, am I? There we go. So stick with that one, persevere. No, you might see it straight away, it might take you 5 minutes, but persevere, it's worth it. Number 13, if 4 numbers have a mean of 10, they have a total of 40. 3 of those numbers add up to 22. If you subtract them, you get the other number. Much easier than the one before it, certainly quicker to solve. Number 14, rearranging. If you want to make h the subject, you want to get h on its own, you need to get rid of a negative 4. So add 4 to the left, add 4 to the right, and you'll get d plus 4. Similar thinking to part B. If you want to get rid of a divide by 3, you need to multiply both sides by 3. On to number 15. Linear sequence, don't get put off by the words. Linear sequence means it's going up by the same amount. It's basically an nth term question with more waffle. If it's going up in 3s, you get your first mark for 3n. Ask yourself, what do I do to my 3 times table To get this sequence, you need to take one away from each one, and that's what gets you mark number 2. Number 16, knowledge of your parts of circles. If you know your stuff, you'll know that tangent is a straight line, chord is a straight line, and arc is a curved line. So it's always it's down to a 50-50. You've got to remember that sector is what you search in. If you were stood at O, shining a torch, that's sort of the range of what, and when you search in sectors. So B is a sector. And segment, like your chocolate orange. Hold a chocolate orange up. They're called segments. That's how I've tried to get students to remember that in the past, with a bit of success, not perfect. When you're adding and subtracting vectors, the only thing you need to know is you add the tops and add the bottoms, because essentially it's a movement. Move 1 to the right and 4 to the right, that'll be 5. Move 2 up and 6 up, that'll be 8 up. That's why it's worth 1 mark only. Number 18, probability trees, but the probabilities change, so don't get caught out. Bag A, keep it separate. If that's a quarter, that's 3/4. That's done. On to bag B. A white is 3 out of 5. So the green is 2 5s. 2 fifths. Part B, work out the probability of 1 red and 1 white. That's top. That's the one we're after. And you multiply. Get your calc if you need to, or just remember it's top times top, bottom times bottom. You can do it quicker than reaching for your calc. But here's where you definitely need your calc. Good old soccer tower. Job 1, labels. Hypotenuse is needed, it's in the question. Opposite is needed. Adjacent is useless, so it's the triangle with O and H. We have a SOH question. You're told to find the opposite, so cover it up. These are next to each other. We need to do a multiply. It's the S stands for sine of the angle. And if you've got a calc that opens brackets, remember to close them. Times by 31. If you want to protect yourselves, do 31 times instead, and that will always help you out. Doesn't tell us how accurate the answer is. Calc says 12.6088. I'll stick to 1 decimal place. Seems sensible. Number 20. It is reverse percentages. Okay, you don't know the original amount. You're working backwards. If you are reducing something by 12%, your multiplier would be 0.88. Reverse percentages means you need to work backwards. You do the opposite. You divide by your multiplier. Calculator spits out 2.5 million. You've earned 2 marks, but don't celebrate. Need to turn it into standard form. Standard form needs a number between 1 and 10. So that's where you want the decimal point to be. And either count how many times it's moved, or remember that millions is power of 6. Either way works. Number 21. Waffle. They love their waffle, but it's multiple choice. D is the number of desserts the chef can make. B is each dessert, so K has to be referring to how many the chef had. And how many the chef has is the number of blueberries in the tub. That's the key bit. To complete the table, whether you want to call it proportion, whatever, I would argue they multiply to make 240. So plug in the gaps. That would be 40. Just do 240 divided by 6. And now do 240 divided by 30. And you don't have to worry about the context the question is in. 22. Every paper loves a probability spinner question. It's fair, it's 6 equal sections, but there's only 4 numbers you can use. Each number appears at least once. Get them in. 5, 6, 7, and 8 are compulsory. The probability of an even number. Well, at the moment, with these being unknowns, even is 2 out of 6. The probability of a 7 is only 1 out of 6. So there has to be at least another 7 in the gap. We now have 2 out of 6 sevens. If we introduced another even number, as in a 6 or an 8, that would change that. And we don't want that. We're told these are even. If we added another 7 in, that would change that. And we don't want that. We're left with the only option. The missing number must be an extra 5. Number 22B, only worth 1 mark. Do not overcomplicate. Add them up. They add up to 1.1. So what's the reason you're going to give? The total should equal 1. They don't. They add up to 1.1. Any words or phrase to that effect? C, I would argue, is the easier part of this question, because C is the intercept. The intercept is the number on the right-hand side of an equation when it's in the form of y equals mx plus c. That's what C is. They've even been nice to call it that. So it must cross at 6. D is the one that's a bit harder. Okay, you could do it by thinking about, well, if the gradient is -2, and that's 6, -2 means go a long 1 down 2. Okay, so by the time you get that, but I don't like that way. Because what happens if the numbers were huge? You're better off having a technique that will always work. So remind yourself that an alternative name for the x-axis is y equals 0. So if we start again with this, your brain might be screaming at you now that x must be 3. Can't be -3. But let's use the algebra to show us why. Adding 2x to both sides shows us why the x-coordinate must equal +3. I know that's a long-winded way of doing it, but it is a technique that will always work, no matter how confusing, complicated and large the numbers are. Counting in steps, you could be there forever if the numbers are, well, above 10 and beyond. The y-intercept, again, that's the easy bit. The x-coordinate of the turning point, that's the tricky bit. Now, they have labelled it for you, but how do you find it? Well, hopefully you'll know that the turning point, also called the vertex, is a line of symmetry. So it's these numbers, the solutions, it's got to be halfway between them. Best way to find halfway, add them together, you get 6, and halve it. And it is just a coincidence. I wish they'd have not given the same answer for that, but there we go. Number 24, Archie's got a biased coin, etc. The best estimate. Now, this is a topic called relative frequency, which is the best estimate It's over here. It's 52 out of 200 or equivalent. Why? Because more trials equals more reliability. The more times you carry out an experiment, the more times you'll realise that it's better data the more you do. If Archie only did it once, what a rubbish experiment. And finally, number 25, I'm going to rely on me and technology. Work out the speed. Speed on a distance time graph is given by the gradient. And you can draw this triangle anywhere, but the larger the better. So I've made it literally as large as I can without going into any guesswork. Now you need to find out how long is the triangle's base. Well, that's easy. That's 5. Vertically, it's a bit trickier, but you've got your calc. Each small square is worth 5. Count the small squares. Hopefully you get 18 of them. The fact is, it's 90. So again, like a lot of this paper, you don't need anywhere near all that working out. Gradient of a line is the vertical divided by the horizontal. Your teacher might have said change in y's divided by change in x's. Who cares how you say it, as long as you get 18 for your 3 marks. And there we go. Hopefully, I've not gone too fast, but it certainly is, I hope, a better explanation than those people out there who are taking 2 hours to say the same thing. That's paper 2 now in the bag. Yep, you've guessed it. I'm now about to record paper 3. Hopefully, see you on that one.